Interestingly, Roland came up with an even more succinct but identical advanced encoding. To see this, let's first have a look at our initial advanced encoding, this guy. And here's now the one that Roland even improved upon. With a double A. Okay, here we go. The generating part is actually the same in both encodings. The trick in making our former advanced encoding even more succinct is to replace I in both rules here. In the first rule, one takes this equation and one expresses I in terms of D and J, and the same actually here in the second one. And once one has done this and adjusted actually the ranges for D, one ends up with these two rules here, which are of course completely free of I and only consist in variables D and J. Looking at the last two rules, and in particular at the first argument of the queen predicates, one may get the impression that these positions may get out of range. That is, here one might get a negative value, here one might get a value that goes beyond n. However, this may not happen because the instantiation of this set as well as this set is driven by all derivable instances of the queen predicate. And this set is delineated by all head atoms. There's all occurrences of queen atoms in the head of rules. And the only occurrences of such instances are in the first two rules, here and here. And here, with these two rules, we can only produce instances from the coordinate 1, 1 to n. This delineates the domain, hence the instantiation is confined to these sets, and we cannot produce values here that are out of range. Okay, now finally let's check whether we really produce the same encodings here. Then let's just run the two encodings. First, our old advanced encoding. So if we do this, we get 381 atoms, 774 rules, 551 bodies. And now we do the same thing with a more succinct version of this encoding. And as you can verify, we get exactly the same number of atoms, rules, and bodies. Well, I hope this convinces you empirically, somehow, that we get the same problem representation in the end from both encodings. And I hope you liked this little postscriptum, and actually there's yet another one waiting for you. Have fun and see you later.